In this video, class 11, we are going to look at how to multiply vectors or rules to multiply vectors. Now, we've already seen that vectors can be multiplied in two ways. One is called the dot product, which gives you a scalar, and the other is called a cross product, which gives you a vector. Okay, so let us first look at the rules regarding dot product or things to remember for dot product. Now we know a dot b, vector a dot b is given by magnitude of a, magnitude of b, cos of the into cos of the angle between vectors a and b. All right, so when I find I dot I, okay, so according to the definition, I should be getting modulus of I, magnitude of the first vector, into magnitude of the second vector, into cos of the angle between them. Now, since we are finding the dot product of the same vector, I cap, the unit vector along the x-axis, so the angle between them is 0 degrees. Now, modulus of I, that is the magnitude of the unit vector, is simply 1. Okay, unit vectors have unit magnitude. So this is also 1, and cos of 0 degrees is 1. So 1 into 1 into 1, basically we get 1. Okay, now this is not just true for I dot I. J dot J will also give us the same thing. You can try it out. And I suggest, of course, you to try this out. Okay, and K dot K will also give us 1. That is why I've written I dot I is equal to J dot J, which is equal to K dot K, which is equal to 1. Okay, you can check this. And the other thing that you can check is, I haven't done this. Okay, you have to check this. Okay, I dot J is equal to J dot I, because remember I had told you the dot product of two vectors, it's commutative. That is, A dot B is equal to B dot A. This is what I had told you. Okay, the dot product between two vectors, it's commutative. So therefore I dot J is the same as J dot I, which is equal to I dot K, and this being commutative, which is equal to K dot I, which is equal to J dot K, which is equal to K dot J. Okay, this is equal to 0. You can verify this yourself. So these are two things that you need to remember whenever you're finding the dot product between two vectors. Now, things to remember in case of cross product. Okay, but before we jump into that, let me show you some of the rules about cross product, which of course we have already discussed. Okay, but still I would like to point these things out. So important things for cross product, I've written the heading to be. So whenever we find the cross product of two vectors A and B, the product vector, that is A cross B, is altogether a new vector. This is obvious. Okay, so when we are finding the cross product of two vectors, A cross B, all right, this A cross B, the product vector, is not vector A, it is not vector B, it's a new vector, of course. Okay, next, the magnitude of vector A cross B is given by AB sine theta, where theta is the angle between vectors A and B. Then the direction of A cross B is given by a right-handed screw. So like I already mentioned, these are things that you already know. Okay, so direction of A cross B is given by a right-handed screw, don't forget. And from the direction given by a right-handed screw, we see that the direction of A cross B is perpendicular to that of both A and B. Keeping these things about cross product in mind, okay, what we do is we now check the rules for cross product. So talking about the rules for cross product, okay, keeping this definition for cross product in mind, let us check this. That is I cross I. So I cross I will be modulus of the first vector, I cap itself, into modulus of the second vector, again I cap itself, into sine of the angle between them, which is 0 degrees. Now since sine 0 degrees is 0, so therefore I cross I comes out to be 0. Now if you verify, you can verify this, okay, and you'll see that J cross J and K cross K also comes out to be 0. Then after we talk about, say for example, I cross J. Now we are multiplying different unit vectors, which of course are perpendicular to each other. So this is I cap here and this is J cap here. So I cross J will give us modulus of the first vector into modulus of the second vector into sine of the angle between them, and we can see that the angle between I cap and j cap of course is 90 degrees. So modulus of I cap is 1, modulus of j cap is 1 since both are unit vectors, and sine of 90 degrees is 1. So I cross j comes out to be 1. So to say, I cross j is also a unit vector. But we need to now find its direction. So in order to find the direction of I cross j, we place our right-handed screw over here, okay, at this junction. And we rotate our right-handed screw from vector I to j. Since we are finding I cross j, so we rotate the right-handed screw from vector I to vector j. So we see that the right-handed screw is rotated in the anti-clockwise sense. Now when we rotate it in the anti-clockwise sense, what happens? The right-handed screw comes out perpendicular to the plane of the paper. Okay, therefore, which means this vector I cross j should have a direction which is coming perpendicularly out of the plane of the paper. Of course, perpendicular to both vectors I and vector j. And it also needs to have unit magnitude. The only vector which satisfies the conditions, that is having unit magnitude and perpendicular to both x and y axis, is a vector along the z-axis, and that is your unit vector k cap. Okay, so therefore remember I cross j comes out to be equal to k cap. We will also see that j cross k comes out to be I cap. Now you have to do the verification, of course. K cross I comes out to be j cap. Okay, now since the cross product of two vectors is not commutative, okay, if you remember, I had told you cross product of two vectors is not commutative, that is a cross b is not equal to b cross a. In fact, we had said a cross b is equal to minus of b cross a. This is what the case was like. Okay, so therefore, since I cross j is k cap, j cross I comes out to be minus k cap. Okay, and j cross k is I cap, so k cross j comes out to be minus I cap. K cross I is j cap, so I cross k comes out to be minus j cap. I suggest you all to note down all of these, and not just note down, remember this by heart. Okay, although I'll also tell you an easier way to remember this. So I'll write ijk like this, okay, and I'll go in alphabetical order in a cycle. Okay, I to j, j to k. Since I want to go in a cycle, so I have to come from k to I. So when I go in this order, so I cross j will give me positive k cap. I cross j will give me k cap. J cross k will give me what? I cap. And k cross I will give me what? J cap. You can see that here. Okay, I repeat, I cross j gives me k cap, j cross k give me I cap, and k cross I gives me j cap. Whereas if I go in the reverse order, not moving in the alphabetical order, okay, that is if I go this way from I to k, so I to k gives me minus of j cap, k cross j gives a minus of I cap, and j cross I gives me minus of k cap. You can check that over here. So what are the rules we finally get for cross product? We get I cross I is j cross j, which is k cross k, which comes out to be equal to 0. And I cross j is k cap, j cross k is I cap, k cross I is j cap, j cross I is minus k cap, k cross j is minus I cap, cross k is minus j cap. So these are the two rules I need to keep in mind whenever we are finding the cross product of two vectors, and these are the two things that we need to keep in mind whenever we are finding the dot product of two vectors. So keeping these rules in mind for dot product and cross product, okay, we need to do our vector problems regarding multiplication.